This is Geometry, Section 4.5, Isosceles and Equilateral Triangles. So, what are isosceles and equilateral triangles? Well, first, we've got three types of triangles. The first type of triangle that we have, which we're not going to talk very much about, is called a scalene triangle. So the definition of a scalene triangle is that it has no congruent sides. As a triangle that has two congruent sides, like this triangle right here, both of these sides are 14, this is called an isosceles triangle. So it has two congruent sides. An equilateral triangle is one like this, where all the sides are congruent. So equilateral, all sides congruent. So, the two congruent sides of an isosceles, so an isosceles triangle has two congruent sides. So the two congruent sides of an isosceles triangle are called the legs, and the other side is called the base. So we've got the legs of an isosceles triangle. So this isosceles triangle right here, we've got these two sides are 10. So the legs are PE and PN, and the base is EN. So, isosceles triangle theorem. If two sides of a triangle are congruent, that makes it isosceles. So if two sides of a triangle are congruent, then the angles opposite from those sides are also congruent. So in this diagram here, we've got if AC is congruent to AB, so we've got AC congruent to AB, these two sides are congruent, then angle C is congruent to angle B. So these two angles are congruent. The way we tell, so what does opposite mean? So opposite means across the triangle. So if I'm talking about the angle that's across from this side right here, directly across is angle C, directly across from this side right here is angle B. So these two angles are congruent if these two sides are congruent. The converse of this is also true. So if I say it backwards, if I say these two angles are congruent, then that also means that these two sides are congruent. So if two congruent angles, then two congruent sides. So examples, add rainbows to the diagram and find the value of the variables. So how do we add rainbows? Well, we've got tick marks here and here, so that means that this side, or excuse me, this angle across from this side and this angle across from this side are congruent. So we would know that 54 is equal to 6p. So if I divide by 6 to solve for p, 54 divided by 6 gives me 9. So p is 9. And for k, so now we have to decide how big k is. Well, if these are each 54, so 54 and 54, if I add those up, I get 108. This angle has to add up to 180 with these other two angles. So we have to figure out what's left over. Well, 180 minus 108 gives us 72. So this angle has to be equal to 72. So we set 3k equal to 72, divide by 3, and we get k equals 24. Same thing for this one. So we've got these two sides are congruent, which means the angle, so this angle across from this side and this angle across from this side are congruent. So 64 equals 5h minus 1. We add 1 to both sides. 65 equals 5h. Divide by 5. That gives us h equals 13. Okay, so same thing. We have to figure out g using these three angles. So for g, both of these angles are 64 degrees, since this one's 64, this one's 64. If I plug h back in, I would get 64 for this angle. So I've got 64 plus 64, which is 128. So I need to subtract that from 180. 180 minus 28 is 52. So 52 is going to be equal to this angle right here. 52 equals 4g plus 8. I would subtract 52. I would get 44 equals 4g. So when I divide by 4, I get g equals 11. Next one. 2 tick marks here and here, so this angle and this angle are congruent, but we don't know how to solve this because we don't know x or y. So we know 4x equals 8y, but we don't know x or y, so we have a problem. So first, we've got this 56-degree angle right here. If we subtract that from 180, 180 minus 56 gives us 124. So I know that these two angles here and here have to add up to 124. And we also know that they're congruent to each other. So if they both add up to 124 and they're congruent to each other, I can take 124 and divide it by 2. So 124 divided by 2 is 62, which means that each of these things, 4x and 8y, both have to equal 62. So if 62 equals 4x, to solve for x, I just divide by 4. So x equals 62 over 4, or 15.5, and for y, we've got 8y equals 62 also, so we divide by 8. So 62 divided by 8 gives us 7.75 for y. These next two, we don't have sides marked congruent, we have angles marked congruent. So now, the converse of the theorem we had before said if the angles are congruent, then the sides across from those angles are congruent. So this side is across from this angle, this side is across from this angle. So these two sides are congruent to each other. So 2n has to equal 3n minus 5. To solve for n, we subtract 3n, get all the n's on one side. 2n minus 3n is negative 1n. Negative 5 is left on the side, so to solve for n, we divide by negative 1. Negative 5 divided by negative 1 is just positive 5. Same thing over here. This angle is congruent to this angle, so these two sides across from these angles are congruent to each other. So 3w equals 36. We divide by 3. We get w equals 12. Okay, a corollary. So a corollary is just an addition to a theorem. So corollary comes from the isosceles triangle theorem that we just talked about. So if a triangle is equilateral, an equilateral triangle is kind of like a special isosceles triangle. So an equilateral triangle is an isosceles triangle where the third side is also congruent to the other two sides. So if it's equilateral, then we also call it equiangular. So that means if all three of these sides are congruent, then all three of these angles are congruent to each other. The converse again is also true, so if 3 congruent angles, then 3 congruent sides. So here we've got all of these angles, we've got all of these angles are congruent. So we know that all of these sides have to be congruent. So the number I have here is 42, so 42 has to be equal to both of these other two things. So 42 equals 3w. I would divide by 3, and I would get w equals 14. So w equals 14. And then we would get 42 equals 2x plus 2, subtract 2, 40 equals 2x. When we divide by 2, we would get x equals 20. Here, for this next one, we've got all three of these sides are congruent, so we know all three of these angles are congruent. So we've got three different variables, x, y, and z, but we can figure out what all three of these angles are, because if I've got 180 degrees total for these three angles, and I know they all equal the same thing, I can just take that 180 degrees and divide it by 3 to get what each one is. So 180 divided by 3 is 60. All of these are 60 degrees. An equilateral triangle always contains three 60-degree angles.